Today we're going to be exploring the Pythagorean identity, sine squared x plus cosine squared x equals to 1. But let's find out the actual proof behind this. Let's say we don't know what sine squared x plus cosine squared x is. Let's just try to figure it out. Well, we know that sine is equal to the opposite over the hypotenuse. And we know that cosine is equal to the adjacent over the hypotenuse. So let's substitute these in. So we get the opposite over the hypotenuse squared plus the adjacent over the hypotenuse squared. Okay, now since we're squaring a fraction, so we get the opposite squared over the hypotenuse squared plus the adjacent squared over the hypotenuse squared. Alright, since these two have the same denominator, we can just add the fractions together. So we get the opposite squared plus the adjacent squared all over the hypotenuse squared. Now what does this actually equal to? Well, let us consider a right angle triangle. So we have sides A, B, and C. And we know that three sides are related through the Pythagorean theorem. A squared plus B squared is equal to C squared. Now, that's not very helpful, but we can rewrite these because we have theta out here. So, instead of writing this as A, let's call this the opposite, because it is opposite from the angle. Then in this case, B would have to be the adjacent, because it is right next to the angle. And C, since it is the longest side, we will call that the hypotenuse. Alright, then let's rewrite it. Then what we do have is the opposite squared plus the adjacent squared is equal to the hypotenuse squared. Okay, now let's divide both sides by the hypotenuse. The hypotenuse squared. These two get cancelled and becomes 1. And hold on a minute. This seems to be the same as this. Opposite squared plus the adjacent squared over the hypotenuse squared. Opposite squared plus the adjacent squared over the hypotenuse squared. Well, that means that all this must equal to 1. So our conclusion is that sine squared of x plus cosine squared of x is equal to 1. Alright, now that you have your newfound Pythagorean identity that sine squared of x plus cosine squared of x is equal to 1, the other two Pythagorean identities are found just by dividing everything by sine squared of x or dividing everything by cosine squared of x. So let me show you. So let's divide everything by sine squared of x. So sine squared of x divided by sine squared of x, well, that's just 1. Plus cosine squared of x divided by sine squared of x, well, what's cosine divided by sine? That's just cotangent. So we can write this as cotangent squared of x. And finally, we have 1 divided by sine squared x. Well, what's 1 over sine? That is just the cosecant. So we can write this as cosecant squared of x. This is our second identity. Okay, let's do the same with the cosine. Divide everything by cosine squared x. Alright, so sine squared x divided by cosine squared x, well, that is just the tangent squared of x, because sine over cosine is equal to tangent. Alright, cosine squared of x divided by cosine squared of x, that's just itself, so it's 1. And 1 divided by cosine squared x, well, 1 over cosine is equal to the secant. So we get secant squared x. And these are your 3 Pythagorean identities, all proven.